All right, let's jump right in. Today, we're going to crack open your computer and solve a mystery that happens every single time you plug something in. We're going to decode the secret language your devices use to talk to your computer. And you know what? It's way simpler and honestly more brilliant than you probably think.
I mean, really, think about it for a second. You plug in a mouse, a keyboard, maybe an external hard drive, and poof, it just works. But what's actually going on in that tiny moment of connection? How does the brain of your computer, the CPU, instantly start a conversation with a device it's literally never seen before? So to figure this out, we're going to start right where it all begins, at the moment of that physical connection. Let's follow that signal right from the port on the outside, all the way deep into the guts of the machine. Okay, so step one is the part we've all done a million times, right? You grab a cable, you plug it into a port, probably a USB port. And that physical connection, that's just the front door. But what happens once you step inside? Well, that's where things get really interesting. Now, once that signal gets inside, it's not just floating around in there. Nope, it immediately gets whisked away onto these super fast digital highways. The techie term for them is expansion buses, but just think of them as the main transit system, the freeways that carry all the information to and from the computer's brain. So, you've got a couple of different kinds of these highways. For the stuff that's already inside your computer, like your powerful graphics card, that uses something called PCI Express, or PCIe. The best way to picture it is like a network of super fast private conveyor belts inside a huge warehouse. But for everything you plug in from the outside, that's usually going to be USB. And that's more like a set of standardized package chutes leading into the warehouse. Two different routes, but they both have the exact same job: get the data to its destination. Okay, so you've got all this data flying in from all these different highways. How in the world does the CPU, the big boss of this whole operation, keep track of everything without just completely crashing? Well, it turns out there's this incredibly clever, super elegant solution. We're calling it the mailbox method. Its proper name, though, is memory mapped I/O. And this right here, this is the secret sauce, the big idea. With memory mapped input-output, or MMIO for short, the CPU basically puts on a pair of glasses that makes everything look the same. It doesn't see a hard drive, a keyboard, or its own system memory as different things. It just sees one giant map of addresses. So get this. Talking to its own memory, or talking to that mouse you just plugged in, it's the exact same move, just reading or writing to a spot on the map. Let's break it down using that mailbox idea. It's really just 4 simple steps. 1, a new device gets plugged in, and boom, the system gives it its own personal mailbox, basically a unique address on that big memory map. 2, the CPU needs to tell it something, so it writes up a little letter. That's the command. 3, it sends the mail by just dropping that letter into the device's mailbox address. And 4, the device is constantly checking its mail. It sees the letter, reads it, and does what it's told. Simple as that. And that's where the real genius of this whole thing shines through. Because of this system, the CPU doesn't have to be some kind of super translator that knows a million different languages for a million different devices. There's no special talk to the keyboard instruction or send a message to the hard drive command. There's just one command: write this to this address. That's it. It makes everything unbelievably efficient. Okay, but wait a second. This can't just be a one-way street, right? It's not just the CPU shouting orders into the void. For any of this to actually work, it has to be a conversation. The devices have to be able to talk back. And that's exactly why you hear the term I/O devices all the time. The I is for input, the O is for output. It's built right into the name. They're designed from the ground up to handle data going both ways. And the best part? That same mailbox system we just talked about, it works perfectly for the return mail too. Think about your hard drive. When you save a file, data goes in from the CPU to the drive. But when you open that file, data comes out from the drive back to the CPU. Same deal with your network card. It takes data in from the CPU to blast out to the internet, and it brings data out from the internet back to the CPU. It's just this constant back and forth, a two-way flow of information. So, when you really zoom out and look at the big picture, you start to see something amazing. The real power of this whole system isn't that it's super complicated. It's the exact opposite. Its power is in its incredible, almost beautiful simplicity. So let's just recap. Why is this mailbox idea so darn brilliant? Well, it boils down to 3 things. First, it's super efficient. The CPU isn't wasting time with different commands, it's always the same move. Second, it keeps the CPU's design simple. It doesn't need a giant, complicated instruction manual.
And third, and this might be the most important one, it's massively scalable. I mean, you could invent some crazy new device tomorrow, and as long as the system can give it a mailbox, your computer already knows the basics of how to talk to it. It's future-proof.
And that really brings us to the big final question. For decades, this incredibly elegant system, treating everything as just another spot in memory, has been the absolute bedrock of how computers work. But now we're plugging in devices that are just ridiculously powerful. We're talking dedicated AI accelerators, things we haven't even dreamed up yet. And you have to wonder, can this beautifully simple mailbox system handle that kind of traffic forever? It's a huge question for the future of computing. Thanks for digging into this with me.